Okay, you can raise your hands. Yes. Only one? Okay. Please raise your hands if you have done the assignment. Okay, so I consider only one. I don't think this is a good count. See, I'm expecting at least a few of you should have done, because when you do assignments only, then only you will be able to understand the things, right? Then only you will be able to get a chance to revise the things which we have discussed in all the past sections, right? So if you don't do the assignments, there is nothing for me to lose. Okay, it is only you who will be losing the things. I have given you only the SQL one, right? It is not the thing which is data frames or RDD. See, SQL is a syntax which you already know. The same thing you need to execute the things in Databricks, right? Okay. So I will be asking the same question tomorrow also. Try to complete the assignment at least by tomorrow. I have given you only the 10 questions, and those are also all the basic ones, like which we have discussed only, and very basic one. I'm expecting many of you should be able to do the assignment by tomorrow. I understand that you are having so many uh, campuses are going on, drives are going on, and you are concentrating on that one. But doing the 10 questions which I have given you will take you very less time. Okay? Okay, I'll share my screen and I'll start the session today. Have you at least referred the document which I have given you? Like, what are the questions I have given you? Because if you don't understand the question, at least I will try to explain you. Okay, no problem. We shall start the session now. Okay. So let me go through the synopsis which we have discussed till now, all the major things, just like a recap. Okay. And then we shall go to today's session, what we are going to discuss. Okay. So majorly we have discussed all the things about what is cloud computing, types of cloud computing. We have discussed how we have how the like okay, how the computing will be there on premises and how it is on cloud. It is the same thing we are doing on cloud. That is what the cloud computing is, right? So we have discussed it in our first session, if you remember or not. Okay. And what else we have discussed? We have discussed processing the data with starting from small range of data to big range of data. So processing the small data using Excel kind of thing is bit easy. But when the data becomes huge and huge, even the Excel is having a limitation, so you couldn't do few operations on Excel. So at that time, what comes into the picture? Data, big data. So big data. So how you can classify any data as a big data? What are the 5 E's of big data? Anyone in the class?
Velocity, variety, veracity, volume.
Volume and one more thing, value. Yeah, okay, good. So these are the 5 ways of big data which we discussed, right? Let me go to that particular slide. So volume, if the data which we are dealing is having huge amount of data, then that is considered as a big data. And variety means different types of data from different sources. See, we have discussed about two sources when we are discussing about this one. One is Azure Blob Storage. So there you could get the data by mounting it. Correct. That is one of the data source. And the other data source, which we have discussed in practical in our classes, is DBFS one. So DBFS is Databricks File System. So inside the DBFS, you can upload whatever the file you want and you can get it right. So you can read it and you can write something to DBFS and all, right? So these are the two things we have discussed. These are the two different sources we have discussed, I should say. And see, we also created the tables, correct? So from that tables also delta tables and in Spark SQL we have created tables, right? So all those are the different kinds of sources. Yes, anyone is having any doubts? Yes, 408, do you have any doubts? Okay, if not, you can mute yourself. Okay. Okay, so volume we have discussed, variety we have discussed, and velocity. Velocity is something which is like data at which at a huge speed the data is coming into your file system. That is what the velocity mean. Correct. So we have discussed this particular thing, but in real time, we didn't discuss it because we need to connect to some of the APIs and get the data for this one. Okay, I don't have any practical example right now to show you the thing which is not batch processing, which is a stream processing. I need to show you. Okay, if time permits, definitely I'll show you that also. And veracity. Veracity is the degree to which the data can be trusted. Means the data to which you are dealing should be like a secured one. Like see, all our data will be encrypted when we give the data, correct? And then they will use it. So this is how it goes on. So when it is being encrypted, we can there is a barrier in between, like the encryption should be done correctly and all. These are all the things comes into the picture when we talk about veracity. Okay, value, extract the meaningful data. So, see, when we are today, I'm opening uh, Teams and all, right? When Teams is collecting the data, it will collect all of our IP address and with what name we have logged in and what is our password, everything it will be having, right? So, out of all these, it should be getting a meaningful data. Like IP address is one of the major column which refers to the meaningful data. So it is that is what I meant. Okay, when I say value. Okay, so that is so these are the 5 ways of big data, and apart from this one, after we have categorized the big data, now it comes to the picture like how we have processed this particular big data. So in our legacy systems, in our legacy system, what we have discussed previously, see, now you are learning about Spark, but previously, what do you have? You have Hadoop for this particular thing, right? So the first thing which has come up and processed this big data is Hadoop. So we have discussed the Hadoop architecture also, and we have discussed few of the drawbacks of Hadoop. Like it is Java based completely, and it couldn't support other languages like the Spark does, right? So these are all the few things which we have discussed. Hadoop architecture we have discussed and drawbacks. And then we have discussed about the new one, which is a Spark, which we are learning in this course, right? So we have discussed what are all the things we have discussed in Spark. What is the Spark architecture? So this is the Hadoop architecture, right? HDFS, MapReduce, and YARN. So HDFS is a file storage. MapReduce is a compute engine. YARN is a mm, resource manager, okay, which will divide the data into multiple sources. 5408, could you please mute yourself? Thank you. Okay, so these are all the things we have discussed about Hadoop architecture, right? And when it comes to the Spark architecture, so the differences between Hadoop and Spark is never about the whole Hadoop and whole Spark. It is only a Spark is replacing only the map reduce of a Hadoop, correct? So that is what we have discussed. That is the main thing. See, even HDFS and YARN can be used inside the, for the Spark compute engine. Okay, we are only replacing the computing engine, but not the file system and the YARN. See, this is up to you what you can use. HDFS it can be, or any local file, local storage means DBFS, for example, is a local storage for a Databricks. So that is what it is referring. It can be of anything. Okay. And resource manager can be Kubernetes and all. Anything you want, you can use any of them. Okay. So this is the major difference between Hadoop MapReduce and Spark, right? We have discussed that one, and we have discussed all the features of Spark, right? So it is having features to process the big data within no time. Like it is more faster when compared to Hadoop. That is what we have discussed. And these are the few differences of Hadoop and Spark. So in Spark, we also have in-memory processing, which we don't have in Hadoop. So in-memory processing means we can use a cache thing for your computing purpose. Correct. I mean, uh, every time you need to execute something, you need to go to the memory and get the data. But you have something called cache, which will hold the thing for certain time so that you no need to go to memory every time. You can directly get the thing from cache and all. Okay. So that is what we have discussed. And performance wise, this is good for batch processing, and this is really faster, real time capable. And it is for stream processing also, this will work. The Spark will work, right? We have discussed all of them. And yeah, so in Hadoop, you have only one which is a Java focused one. But in Spark, you have multiple languages, SQL, Scala, R, and Java also it has been implemented. So this is what we have discussed. And here, see, fault tolerance is managed by Hadoop by data replication. Data has been replicated, and that is how it has managed. But the fault tolerance here in Spark, it is managed with respect to RDDs. Because see, what RDD does is you have multiple stages, correct? Out of those or multiple stages, you will be you have multiple tasks. So all these multiple tasks, upon all these multiple tasks, you will be partitioning the data again, and that partition is RDD. So that is what we have discussed through a diagram, and we have discussed that particular thing, right? And apart from this one, what we have discussed, architecture of Spark. Where is this architecture of Spark? Hmm. So Spark job execution. Spark job execution will definitely be one of your interview question. I'm telling you this again and again because you will be focusing on this one. Okay. So what it will do? There will be a program, and when you execute that particular program, immediately what this cluster manager will do, it will allocate the resources to multiple stages. Means first this particular job will be divided into multiple stages. So each stage is what you will say, it is a worker node. This is a master node, and this is the worker node. Master slave kind of thing. It will do. It doesn't do any work. I mean, it doesn't compute anything. What it will do instead, it will instruct the things to these slaves, like do take these resources, do this thing. So this is what it will instruct, and this is doing all the jobs. So that is what it is. And here in each, for each worker node, you will be having a executor. So, and inside each and every stage, you will be having multiple tasks. So each task will be executed. One depends on what operation you are doing. Okay, so it is how it will be. And apart from all these, you have also discussed about DAG, directed acyclic graph. So each job has been divided into stages, and stages in turn divided into tasks. So this is how it has been in DAG, correct? And inside the Spark, we have so this is Spark. We have discussed, right? The Spark job execution. Now that we have discussed about the all this, now in practical, what are all the things we have discussed? How to initialize the Spark session? Mainly, we have discussed, right? So we that is one thing you need to understand. And apart from initializing the Spark session, apart from initializing the Spark session, what else you have done? We have imported the Spark context, right? So this is Spark context. Using this Spark context only, we have created RDD, and we have worked on RDD. So what is RDD? RDD is a fundamental source, a fundamental unit of this what I should say. That is a fundamental unit of Spark, I should say. Okay, so this particular RDD is having uh, three things, three operations. One is transformations, actions, and persistence. Correct. So all these three we have discussed everything in detail, and everything in practical we have discussed. Correct. So uh, transformations are lazy in nature, whereas actions do, when actions are applied, then only the transformations will get executed. So this is also one thing which we have discussed in detail. And apart from that, what we have discussed, see, when you're working with the Spark, you can work on 4 different languages in Databricks. Okay. One is SQL, one is R, one is Scala, and the other one is Python. So Python will be the default language whenever you create a notebook inside the Databricks. Correct. So that one thing you need to remember. And we also discussed the differences between Spark and PySpark. Correct. Spark, PySpark is nothing but a framework inside the Spark. Means when you work with Python environment inside the Spark, that is what the PySpark mean. So we have discussed the differences. Correct? Spark is a processing framework, whereas PySpark is a collaboration of Spark framework to work with Python language. So you already aware of this particular major point, right? Why I'm going in detail of each and everything today means it's means mm, while I'm revising, if you missed something previously, upon revising the things, at least you will be able to catch up, right? I mean, even though you have multiple things in your bucket, now that if I revise the things, you will at least memorize the things, even if you don't do revising the notebooks every day and this particular PPT. Correct? That's why I'm doing this. Okay. And what else we have discussed in this particular one? We have various libraries that imports we import for a specific functionality in PySpark. But in sorry in Spark. But in PySpark we have one particular thing that is py4j means Python for Java and vice versa. Java for Python library is used to facilitate working with Spark. Okay. So this is the major thing we have discussed. And whenever you execute a program inside the Databricks, we have also discussed like uh, how to create a cluster and inside the cluster what are all the things we have, each and everything we have discussed. Spark UI and Spark Master UI, job stages, DAG we have seen, each and everything we have seen, right? So see, whenever you do something now, like whenever you execute something, at that moment you will be able to see the things. Means what I meant to say exactly means whenever you execute the things and see the DAG and how it is executing, how many stages it is having, it will improve your understanding. Means you can correlate the things and learn it from that particular point. Okay, so let's not go in depth of that one. And so RDD operations. So RDD operations are transformations and actions we have discussed. And again, the transformations are of two types. One is narrow and wide. If the shuffling is not required, that is narrow transformation. And if the shuffling is required, then it is a wide transformation. Correct. So in wide, particularly joins will definitely be in wide transformations. Correct. So, see, when someone asks you what is the narrow transformation and wide transformation, you will be able to answer this. But they will ask you with the examples. What are the examples for narrow and what are the examples for wide? And you need to explain in detail. So, in wide transformations. See, why shuffling is not required for narrow you need to tell, and why shuffling is required in wide transformations is also required. Correct? So mapping the things. Mapping the things will not require the mapping, shuffling inside the things, right? Means, see, mapping the things. For A, no. For example, A should be mapped to B. In such a case, what it will do, it will take A and it will take B and then it will map directly. There is nothing like it should shuffle the things and do it, right? It can do without shuffling also. And when you say union, union is nothing but just joining, not join is different and union is different. Union is just appending the things, one appending one thing to the other, one table to the other table is what union does. It will never require a shuffling. So this is the major thing you can explain. Okay. And when it comes to join, so join based on the join condition, you will be doing it. And so for you need to take the condition first and then uh, divide the data sets and then you will join the things. Correct? So that is what important while you are working on joins in wide transformations. Okay. And intersection is taking the common part. So in order to take the common part, definitely you need a shuffling, then only you will be able to get the things. Correct. So that is what we have discussed. And so when you create an RDD, how you will create Spark sc dot RDD, correct? I mean, in from Spark context, you will create RDD, correct? then only you will be able to create the RDD. Means Spark context will be helping you to uh, what it is helping you to work with a very ground level data. Okay, so that is the first part we have discussed, RDD, and again we have discussed on data frames. So in data frames, what we have discussed? In data frames, we have discussed the row functions, column functions, datetime functions, aggregate functions, window functions majorly, and we have discussed all these things which are required from data frame point of view. So when you create a data frame, you will say that spark dot create data frame of, right? So that is what the data frame can, that is how you can create a data frame. Means from Spark you can create, but RDD you can create only from Spark context. So this is the difference between how you create a RDD, how you create a data frame. These are the two things which will never collide. Okay, so make sure that you will always have a strong basement on creating the things. Means creating RDD or creating a data frame. These two are having a different things, because whenever you create a RDD, you will definitely need to first initialize the Spark session, and then only you can create a Spark session, and then Spark context, then only you will be able to create a RDD. But this data frames does not require all this. It what it requires is we need to import all the things, like whatever. For example, you are working on this window functions, so you need to import it spark.sql. From spark.sql, import window. Then only it will import the window functions. Then only you will be able to do the things. So that is how the data frames are. So data frames are a little bit equal to our SQL only. But see, there will be definitely a syntax variations. But you can identify, like see, when you know the SQL, working with data frames is easy, definitely, because the syntax a little bit differs, but yeah, you can handle it, no doubt on that one. Correct. And for RDD, when someone asks you about RDD, how many partitions the data is there? So default partitions are 8. It depends upon the course we are using. Okay, but when we are working with community edition, for you and me, everyone, it will be 8 partitions. See, whenever you work on data frames also, when you see the default partitions, it will be 8 only. Okay, manually you can divide the partitions in this particular what RDD, and also you can divide it in data frames also. Okay, and using gloom function, you will be able to see into which partition what data is loaded. So that particular thing you can see. And gloom is again a transformation but not an action. Gloom dot of dot collect off, until you don't give off collect, it will not show you what how it is actually. Okay, even if it has been separated, it will not give you. Sc.parallelize off is what RDD creation. When it comes to data frame, spark dot create data frame of, or 2df off. These are the two things which we have discussed. Correct. So majorly, I have covered all the things from these 2 points. Okay. Why I'm telling you again and again is because uh, from your point of view, from your fresher point of view, they will be expecting the strong basics. Then only you will be able to understand all the things, right? So that is why I'm repeating these things. Okay. See, since today is our first session after weekend, I'm repeating it, but in between I may not be able to do it. Okay. And so in data frames, we have 2 extra joins apart from inner, left, right, and full outer. What are those? Those are left semi-join and left anti-join. So semi-joins will, what it will do, it will take only the common part. No, no, no. I should not say common part. See, A and B, two tables are there. When you do left semi-joint, from the left table, which are all the records that have been um, matching with right table, then only this left table records which are matched will be returned. Okay. The anti-join is a little bit opposite of this one. Means it will take the one which is not matching from the right table. So that is left anti-join. You got a full clarity on semi-join and anti-join, right? We have discussed this particular thing doing practical also. So I hope you are good with these two particular things. Even if someone asks you, you will be able to tell, correct? And all these date and time functions are all similar to your date and time functions in SQL. So we have discussed all of them also. And when it comes to Spark SQL, here also we have discussed how to load the data. Like mm, if there is a so SQL means a structured query language, right? So it means that it is expecting the structured data. So this is CSV file, TSV file, Parquet file. All these are Cs. JSON file is not a structured format thing, okay? Compulsory because it it will not have the header and rows kind of thing. It is a different thing when compared to the other ones. Means even in your Excel CSV file, you may be able to see it in a table kind of thing. Means for this particular one, this is the first column. Sorry, first row is a header, and remaining all are data in for that particular header. We shall say, but JSON is not like that, and Parquet is also not like that. You couldn't actually JSON format you have seen, right? Each and everything inside the Google or something, whatever we are doing, everything will be having the data either in XML or a JSON format. So all these data sets will be in JSON and XML format only. So we need to be very thorough on this particular JSON one, parsing the JSON files and all. Okay, so that is the unstructured data we are dealing with. Okay, but we know how to convert that unstructured data into structured data when you are working in Spark SQL. Just creating a data frame, and out of that particular data frame, what we have done, we have created a temporary table, correct? So that is one thing we have done. And we do discussed all the things like how to read, how to write, each and everything we have discussed, correct? And for you, what I should say is my issue with this particular portal has not been resolved yet. But what are all the things practically we could do? I will be doing it here. But the one which I am going to tell you, which is theory, I will not use this, okay, for our convenience. And what else we have discussed? DB utils. So DB utils also major topic. DB utils, what do it do? It is providing the utilities, Databricks utilities. So from that module, you are able to parameterize your own notebook, and you can call one notebook from another notebook. And also you can throw a value when you exit this particular notebook. So all these are possible. And see here, workflows. This has been disabled for me, but what this workflows will do means it will help us to schedule a notebook actually. Okay, so in general we have discussed in depth of all these things, right? So this cluster is having what runtime and what is event log, what are libraries. Libraries are again a third party kind of thing. Means the thing which Means if the Databricks couldn't support a few features, you can import a few libraries and work on it. Okay, so that is what the library mean. Okay, and how the things will be inside the Spark UI we have seen, right? Stages and all the DAG point of view we have seen all this, correct? So that is the thing, and catalog, DBFS and database tables. So we have discussed on these two also, and so I have discussed all this, and recently we have discussed things like partition data, how you can create a partitions when you work on database tables. That one we have discussed, and partitions are inside which one, which format of data we have that particular one, that is Parquet file. Okay, Parquet file will always have partitioned data. So it is very helpful. I mean that particular file format everyone will use majorly, because it is having a capacity to uh, minimize the storage capacity. Like if for example in CSV it is 50 MB, when you convert it into Parquet, it will definitely decrease to 75%. Okay, so that is how it is actually. And in Parquet file, you can create a partitions also. Correct. Manual partitions we have seen, and also dynamically how you can create a partition tables. That also we have seen. Correct. So remember all these things. And what else we have discussed? I hope we are good. I mean, I have clearly mentioned each and everything, right? So now that we have discussed all these, we have also discussed a few things in Azure portal, right? In Azure portal, you have seen storage account. Storage account is having containers, and in each container, you will have multiple file format data, and you can have huge file size, huge huge sized files also will be there. Okay, so now that we are going in depth, means how you can utilize this particular Databricks notebooks you have seen till now. Okay, so from now onwards, what I will do, I will explain you few terms. Okay, what is data lake, what is delta lake, and what is its structure, and why we are using delta lake, and all this I will be explaining you each and everything. Okay, now apart from that particular thing, so how we will ingest the data, right? See, I'm creating one CSV file directly and uploading it and taking the data and all. But think from a big data perspective. You will never be having the data in a structured format, correct? You will always be having the data in a different file formats. So it can be of any format. So from that huge data point of view, you need to understand like which makes your processing better. So you need to identify the things. Means when you know the drawbacks of one particular tool and you know the advantages of another tool, then only you will be able to take a decision like migrating from this to that, and which one to use is better, which one betterly we can use. It will help you, right? So today it will be a completely, not completely, mostly a theory part which we will be discussing. Okay, I have given you all the wings to fly, like how you can ingest data in partitions, and how utilizing the DB tools and parameterizing the Databricks notebooks and all. And see, only thing what is left is utilizing them in your real time. Okay, as I told you earlier, we are near to end our course. Okay, it doesn't take much time to close all these courses. Okay. So mostly major topics which are left are Unity catalog and this medallion architecture means in general, if it is a big data, how we usually ingest the data means how many layers, what should I say? Um, see, if I click here and if I see the, no, wait, see, even if I'm doing multiple things on this particular thing, save and share more tools, see, name window and performance, task manager, developer tools. See, if I click on this developer tools, you could see something in HTML written here, right? So this is the one uh, you could see means see uh, it is taking the Google is taking my data, like what I have opened and how I have opened means by searching it, or if someone has sent me link, I have opened it, and what is my IP address, at what particular time I have opened this particular thing, and how much time I have spent on this particular thing, and each and everything it is taking me. Correct. So uh, uh, this is a very huge thing. See, not only my system, even all your systems will be holding all this data. Okay, no matter what you're using, be it a mobile or a system or a laptop, whatever it is, you will definitely be able to see this all this raw data and all. Okay, so uh, to uh, means what I meant to say is, see, data will be in this format when it comes. Means this is very raw, very raw data. Means you haven't done anything. You haven't at least uh, taken a fields which are required. It was not done yet, right? So when you take all this raw data, then that is one bronze layer. When you process little bit means ticking only important columns and all, and little bit of processing will be done, so that is a silver layer. And then it comes to a transformations completely means with respect to business, how you are implementing the logics and deriving the data and all comes to the gold layer. So all these particular things we will be discussing further. Okay, for now I'm closing this particular thing, and I want to tell you one thing about the Databricks. Okay, let me open my. So I have taken a Databricks architecture. So let's understand from Databricks point of view how the architecture is. Okay, so uh, be it any cloud like GCP or AWS or Salesforce, whatever the cloud is, keep it aside. Okay, I'm taking example of Microsoft Azure, but it can be of any cloud. I'm telling you. Okay, so this Microsoft Azure means we are using the Databricks community version. Uh, but in real time, you will be utilizing any one of the cloud, AWS, Azure, or GCP, or Salesforce, whatever it is. Okay. And what you will do, you will process the data. So, see, you need to understand, right, what is managed by you and what is managed by your cloud platform. That one we are going to discuss now. Okay. So, in any cloud platform, this is how it will be. Whenever you create a Databricks workspace, what it will do, it will deploy the Azure Databricks workspace along with a storage account. What does the storage account do? It is having all the logs. Okay, what the user has done. User means me. For my workspace, it is me. Okay. When I'm working to any organization, each and every organization will then divide the will take the subscription from Azure. And then inside the subscription, what are all the resources you want, you will be creating. Okay. So that is how it is. You already know that particular thing. Correct. So, well, mm, since this is a Databricks is a workspace which we are talking now, what it will do means, see, Microsoft Azure, when you deploy anything, when you create a cluster, now what it will do means Databricks will uh, means Azure will connect to the Databricks and Databricks will deploy a Databricks appliance. Okay, means the refrigerator kind of thing. What you could say means refrigerator. For using a refrigerator, are you preparing the each and every part of refrigerator and you are using it? No, right? What you're doing, it was built already. You're just buying it and then using it for your purpose, be it whatever the purpose is. Means storing vegetables or storing eggs or whatever it is. It is up to you how you use that particular thing. You can keep anything. So until you buy that particular thing, it is their responsibility. But when you have any issues with that particular thing, no, definitely whoever it is, let's say LG refrigerator is there, then you will contact the LG support team. They will come and they will fix the issue and they will. So this is also the same thing we are doing on the cloud. Okay, you are buying that particular thing. You are paying for it. Definitely, I'm saying is this particular thing. Definitely, your organization will be paying to each and every cloud provider. Okay, whatever the resources are you're using, you will be paying for all of them. Okay, so in Azure also it is the same thing. So what the Microsoft Azure will manage, you will see now, and what are the things you will manage by yourselves. Means Databricks, you bought something, right? So it is not the thing that everything will be handled by only Microsoft Azure. It is the thing that you will be only know what data to be taken and from where it should be taken and all, right? Means the data part you are handling means it is divided. Databricks architecture is divided into two parts. One is control plane and other one is data plane. Okay, so control plane, whatever it is there, it will be handled by Azure only, Microsoft Azure. But data plane, what data you want and where to take the data and how the data should be. Means if you want to convert from one file to another file, one format of file to another format of file is also possible, right? So that's what I'm trying to tell you. Means you are able to convert it, right? So all the data part means DBFS and all Databricks workspace, like you are scheduling a job. Okay, that is up to you. Means you'll schedule it at any moment. That is up to you. But executing that particular thing at that time is what Azure manages. Okay, clear everyone? This particular control plane and data plane. See here in this particular pic, it is clearly mentioned. Databricks control plane means this particular one, and Databricks data plane means this one. Means storage it will give you. You will store something. It is none of that his business to ask what data we are storing. Okay, storing means storage capacity it will give us. Computing capacity means it is giving you computing capacity, but it doesn't ask you like mean for example you have in Databricks. So see, in Databricks training cluster, see all this Apache Spark 3.3.2, Scala 2.12. So this is the versions it has provided. But for you and for your project, what is really required is only can be chosen by you. Okay, so that is what I'm trying to tell you. So it will provide you all the resources which are required, but it will give you all the freedom to how to use them in a optimized way is up to you. Okay, create or delete a Databricks um, is there within the control plane. Means once you have created now, what it will do, how many clusters you want, you can specify that particular thing. But who is giving how many those clusters to you? It is a Databricks, Microsoft Azure Databricks, correct? So that control has been maintained by Databricks only, and you are just using that particular thing. Okay, how many worker nodes you want, and minimum how many you want, maximum how many you want, and what version of Apache you want to use, and what version of Scala you want to use, and what is the Databricks notebook language you want to use. You can change it, obviously. It is by default Python, but yeah, you can change it. Okay, so that one you can take, and also um, here, if you see storage, computer networking. See, networking is all associated with everything, whatever you work on. If you, I mean, don't think that there is no networking in your course, okay? Means networking means, see, the cluster manager is dividing the what dividing the data into multiple stages, and each particular stage is having executor and having multiple tasks. Executor will execute all the tasks. Means, see, and what it will do, it will collect the results. Cluster manager, correct? From all these particular things. Means if there is no network between each and every stage and the cluster manager, how it will be able to send the instructions and how it will be able to take the instructions? Networking is everywhere. Networking is everywhere. Only the thing is, it has been optimized to you when you are utilizing the resources. Okay, it doesn't mean that networking is not required. Okay, networking is each and every moment. Means in every resource, networking is there. Let me show you. See, if I go to this particular storage account also, here if you see security plus networking. Okay. So networking, if you see inside the network security and networking only, you have this access key and the shared access signature, okay, and this encryption level, whatever all you want, firewalls and virtual networks, okay. So see, what enable from selected virtual networks and IP address. If see, I have taken enabled all the networks, means anyone can access this particular thing. But if I say enabled from selected virtual networks and IP addresses means, see here, it is asking add existing virtual network or add new virtual network. So here you need to give the IP addresses, range and all. So for only particular IP addresses only, you can be able to for the those particular IP addresses only you can enable to use the resource, this particular resource. Okay, so this is how the networking will help you. Okay, let's not go in depth of this particular thing, but I want to make sure that you are well known of these things. Means networking is also part of every resource, and it should be managed correctly and properly. Okay, so see, when you're working on trail versions and your community versions and all, there is no point of networking, security, and all these. Okay, because everything will be handled by your whatever the cloud you have chosen, they will take care of all this. But When you work actually, na, then everything comes into the picture. Means, see, every day I'm working on this platform only, Azure platform only. But every day means this particular thing, what Azure will, Azure, not only Azure, every cloud platform is trying to enhance the things every day and give you new features every day. Means, see, if there is any security issue, you will be able to recognize by some suggestions. Means, see, there is a security incident happened, means it is highlighted by Databricks, or sorry, not Databricks. It is highlighted by your cloud platform only. You cannot identify it actually. Means, see, when you add a range of client IP addresses, means from this particular point to this particular point, you can take all of our IP addresses and you all should have access, you told. For example, if someone has dropped, means someone has joined and left the organization, then that particular IP address should not be there, na? So you need to remove it, right? So it is all handled by Databricks, sorry, Azure only, Azure platform only. That's what I'm trying to tell you. All the management things are handled by Azure platform. Okay. And data platform, how the data should be, what data should be there, and how to ingest the data, how to retrieve the data, read data, write data, all these things we are dealing. Okay. And how many clusters we want, we will take, what type of cluster, means what configurations we want, we will take. So all those which were chosen by us is of data plane. Something which is not in our hand, which couldn't be controlled by us, is in control plane. Okay, clear everyone, this particular architecture, what I'm telling you, data plane and control plane. Now you will be able to correlate, right? What is data plane and what is control plane and all. Correct? Okay. Now we will go to the next one. Okay. So we have seen like storage account, simply storage account we have seen, and DBFS. These are the two things we have discussed in practical throughout our session, right? But in general, means in order to understand you by what is Delta Lake, let's go little bit history about what is this data warehousing means and what is the data lake means. Because upon the data warehouse, traditional means when you go back years back, people used to have only data warehouses only. Means the data will be there in a tables, and you will be writing some queries upon that one and you are processing that. So that is the data warehouse kind of thing. When it comes to data lake, it has accepted the various file formats, like be it any format, be it a structured one. See, it has accepted the structured one, and it has also accepted the unstructured and semi-structured also. So, uh, before a delta lake, let me give you little bit of brief. Okay, little bit of brief on these two. Okay. So data warehouse means our traditional things, like our traditional systems like Oracle or Microsoft SQL Server, MySQL. What else we have? Post, no, let's not go with that one. So, okay, these are enough. MySQL, Microsoft SQL Server, and Oracle. These are all the servers we have. So, these are all the servers which we have years back. Okay, so those are all data warehouses. Means we should say it as a having the data in a relational databases. Means we do get the data in a table format only. and we will process the data, and again we will convert it to the table only, and that particular tables are being used, correct? So that particular tables are being used for all the purposes. So that is what the data warehouse mean. Okay. So understand with respect to the differences. Okay, data lake is nothing but, see, this particular storage account is Azure Data Lake Gen 2 1. Okay, data lake. I'm saying data lake, not delta lake. It is a data lake. Don't confuse between data lake and delta lake. Okay, we will further discuss on data lake and delta lake also. Okay, and so data warehouse, no? So this particular data warehouse is having a structured and processed data, whereas this data lake is having structured, semi-structured, unstructured, raw, whatever it is. It has accepted all the things. Okay, schema on write, schema on read. Processing is how it is schema on write and schema on read. Sorry, storage. So how the storage is expensive for large data volumes. It is expected, right? Means for storing the small amount of data, it will cost less. But for storing the huge amount of data, it is definitely expensive, right? When it comes to the data warehouse. So that is what here it is mentioned. And data lake also. See, designed for very low cost storage. Means you can upload a few many things and you can do many things. Upload whatever the file format and whatever the file size you can upload. But it is of very low cost. That is why data lakes are very famous before 2 years. Means uh, before 2 years, data lakes are very famous, and everyone used to take the data from data lake only. Okay. For data lake, we have separate thing. Data lake Gen 1, data lake Gen 2. We have two things. Okay. Uh, we have used those two things also, uh, because whatever the file size is, it will always consume very, it is very less expensive. That is the reason, main reason why we use the data lake one. Okay. And agility. This is less agile and fixed configuration. This is highly agile and configure and reconfigured as needed. Okay, that's what it is saying. And security. Mature and maturing means, it is from security point of view, it both serves the same actually. Means to add any user to any server it requires a UI, and they will add manually only. And here also in data lake also you need to add it manually only. Okay. Users, business professionals, here they have given data scientists and ETAL, something they have given. But yeah, so see, data scientists will also use this data warehouse also. It is not the thing that only data scientists will use this data lake, and data engineers will use something else. Okay. Like, everyone can use data lake and everyone can use the data warehouse. But depending upon how you what how you want the data to be. Okay. So actually this data lake, mostly what I have seen is the tables inside the storage account are created manually and all. Okay. But data warehouse is having only one feature, that is means, see, in data lake you can have multiple files, file formats, CSV, TSV, etc. And also database table, not database tables, but tables you can have. Okay. In data lake, in data warehouse, you have only one option. That only one option is relational databases only. Okay. That's what. So you have identified the few drawbacks of data warehouse, right? Means it is always required to have a data in a structured format when you are working with the data warehouse. But in data lake, it can be of any format. So that one particular thing you have identified and understood, right? So there are few data drawbacks of this one. That's why this has been implemented. And again, now this is also having from a few data, sorry, a few drawbacks. That's why we have implemented Delta Lake. Now, let me go to the next one. Okay. Give me a moment. You can take a break of 2 minutes. I will also take a water break and I will get back. I hope you all are back again. Okay, I'll take this as yes. And so we till now we have discussed about what is the difference between data warehouse and a data lake, right? So diverse file formats is the one major difference which we have discussed, correct? So that's what. And now we shall discuss a few things on this data lake and delta lake. See, data warehouse is not on-premises one. See, data warehouse is also a cloud one. Means I can create a Microsoft SQL Server not only on premises, but I can also create it on cloud also. Okay. So, uh, what it is also upgraded to cloud, but there are few drawbacks because we can get the data via only some tables only, not through any format like CSV or TSV. Whatever the file format you want, you cannot convert the data like that, right? So that is the differences. Okay, now that we have discussed these two, we will go to the next one. Okay, so data lake we have seen. Now that we are using the delta lake. Okay, so see, Delta Lake means nothing but this particular workspace is there now. Databricks workspace. Whatever all the tables we have, no, not this catalog. Okay. So see, inside the DBFS file store. See, this is inside the data input. You have a, these are all only follow format folders. Okay. 1 minute. Okay. See, I have uploaded the data frames sample to sample in text file, training text file I have created. Okay. So inside this particular one, inside input, I have these many CSV files and these things, correct. Inside the CSV, all these are there, correct. So what I'm trying to tell you is this DBFS whatever the files like CSV file, TSV file, or JSON file, or whatever the file you have, those are all different file formats, right? Now that upon this CSV and TSV and whatever it is, how you can convert those particular things into mm, our what into our delta tables, I will show you now. Okay. So whenever you work on Databricks, you will be definitely working on delta tables only. I'm repeating it, delta tables. Okay. There is a difference between delta table. There is a difference between delta lake and data lake. Okay. See, whenever you are working on this one, uh, you are appending the data actually. You are appending the storage account data, means data lake, whatever you have taken, that particular data, you are appending it to your Databricks workspace, and then you are working on upon it. Okay. So means you are taking the diverse file formats data and working processing it. But it doesn't mean that you are creating a delta tables. Okay. Delta table is always in a Parquet file format. Okay. Parquet file format, and also it is a partitioned data. Okay. Let me go to this one and show you. See, Delta Lake is an open source table format for storing the data at scale. It improves the reliability, performance, and developer experience of regular data lakes by giving you below things. Means what it is saying, um, see, both are storage things only, but there is a little bit of difference and little bit of catch you need to take. Okay, little bit of catch is there. Try to understand it. Okay, because in your throughout Azure, whatever the cloud platform you work on, if it is a Databricks one, throughout your career, you will be hearing this particular word, which is a delta table or a delta lake or a data lake. Okay, understanding all these differences is mandatory. Okay, then only you will be able to understand all the things in detail. Okay, so delta lake is also a open source table format, but see, it is not a table right away. It is saying table format only, not a table directly. Okay, understand it, right? You understood it, right? And what it is saying, it improves the reliability, performance, and developer experience of regular data lakes. Means upon the data lakes, you are creating the delta lake. Okay, means I hope now you could correlate, right? Means whatever the CSV file, TSV file, JSON file, whatever you have taken, whatever you got, all those, you are utilizing all of them, and you could convert them into the delta tables and use it inside the Databricks. Correct. So that's what it is. And let me go to this particular slide and show you. Okay, see here. Data lake can take any raw data format. Okay, data format, it can be of any raw data. But in Delta Lake, it is saying Parquet JSON upload. Okay, mostly it is in a partitioned format only. And it is a Parquet file format. Okay, and data processing, batch or stream processing. Here also it is batch or stream processing. But see, ACID transactions are not available in data lake, but in delta lake, yes, it is there. Atomicity, consistency, and see, we will discuss on this in detailed in further of this session. Okay, and schema enforcement. Here it is not there, but when it is delta lake, schema enforcement is must, and reliability is lower, and it is higher cost. Data lake, as discussed, it is still the lower of cost. Delta lake is again a higher cost. When you see the differences between data warehouse and data lake, here also data lake is the cheapest one. And when you see the differences between data lake and delta lake, here also it is of the cheaper cost. Okay, that's why many of the organizations still use data lake. Means still use data lake. No, I should not pass this statement. What I should say is it will use the data lake, and upon this we are creating a delta lake. Okay. So when you search like a delta lake, it will not show you here. Means that is not any resource. Delta lake. See, I have typed the delta lake, but it is not there because it is not any resource. Means you need to create it upon the data lake. Means it is with respect to Databricks environment only. But data lake is not like that. It is a storage service, particular storage service. Okay. See, here you could see data lake storage Gen 1. Similarly, Gen 2 is this storage accounts which we are discussing. Okay. So, see, previously data lake Gen 2 is different from Azure storage account. But later, what they have done is they have merged data lake Gen 2 to storage account. That's how this has been evolved. Okay. So analytics is there, na? So whenever a job has been executed, you could see those job analytics inside this particular thing, and you could view it. Means I'm telling you with respect to Hadoop. Okay, when I worked on Hadoop, uh, we used to check the job how it is running and at which is job stage it has failed and what is the stage is about, all each and everything we used to check it here. Okay, but now it has been deprecated. I mean, not deprecated, but when we are using data like Gen 2, it is no point of checking the things in data like analytics, right? See, in Databricks, whatever the job you execute, it will always create few jobs and you could see it from this portal only, no? So that's what. It doesn't require any separate portal or separate UI or separate resource. Okay. So where are we? Huh. So clear, right? So now what the data lake and what is the delta lake? Here are the few things I have listed. Okay. So in data lake, we will be having multiple sources of data. Means it can be in any file format. That is the one major thing. Second one, cataloging and indexing to you uh, to give you an overview of what kind of data is in data lake. Means in data lake, no, the folder structure which we are seeing in our Azure data, what Azure blob storage we have seen, right? So inside the blob storage you have containers, and in each container you have folder structures. In each and every container will have multiple folders, and inside each folder you will be having multiple files. Similarly, data lake also that is what this is saying. Means what data you are referring to, you could be able to identify with respect to the folder structure. Okay. And access from different teams and roles for using the data downstream. What it is saying means uh, different teams can access the data which you have. Means I will access the data from my upstream. Means the team which is providing me the source tables and all, I will access from them. And I will also give some data to my downstream, right? Means whatever the data I'm giving, they will utilize it and they will further process it, right? So that is downstream. They will also access my tables. So the access management is good in data lake. And here what it is saying is the ability to perform the data science and machine learning analysis. It has the ability to perform the data science and machine learning analysis upon this data lake, it is saying. Okay. And when it comes to delta lake, see, uh, we have a few drawbacks. And to overcome that one, we have delta lake also. Means, see, hmm, what the first one it is saying ACID transactions for reliable reads and writes. Correct. So understand the context of this particular thing. Means atomicity, consistency, whatever here we are discussing, it is able to do only via delta lake, not through the delta lake. Sorry, data lake. Okay, so that is what it is saying. And before going to this into this particular thing, I will show you how to create a delta table. Okay, let me create a data frame. Okay, data frame equals to spark dot read dot CSV I'm taking, and let me take a file from catalog. Let the file store. Okay, let me take this particular one. So this is the one which is from my DBFS. Okay. See, I don't have access to take the things from this storage account and show you, because again I need to mount the things and do the things. Okay. That's why I'm simply taking the example from my DBFS and showing you. Okay. So what else we have? Header equal to true. Infer schema equals to true. So this is how we used to give, right? Df dot show off. How it has showed you the data. Hmm. So this is how it is showing, right? So now it is in CSV format, and now I'm going to convert it into a delta table. Okay. So df dot means see, let me create a delta table, then I will be able to show you how to read it. Okay, it is the same thing. How you read the CSV, you will be able to read the delta also the same. Okay, df dot write dot format. Which format? Delta. Okay, format dot option. Option header equal to true. Okay, so this one, and where save. So see, I'm writing in a delta format and header equals to true. And see this particular data frame. This is the data frame. I'm writing it in a delta format and reading header equals to true and save as. We need to give some path, right? So that's why I'm taking this delta slash sample. Okay. Let me click on shift enter and I will show you. It is creating the delta table. Okay. Path must be absolute. Okay. Let me go here and take the path. Okay. Inside the delta, it should be saved as a sample. Before also I have given the same, but what is the difference? Why we got error means before the slash was not given before, but now I have given it. That's why. Okay, so let's go to this catalog and see how it is. Okay, actually, na to see. mm, this is the sample which we have created. Let me go inside it and show you how it is. Each and everything inside this particular sample folder is in a Parquet file only. Parquet format only. How I can show you? See, if I hover on this one, you could see right at the end it is saying snappy.parquet. Okay, part 0000 and something is there, and it is saying snappy.parquet dot snappy dot parquet. Okay, so this is how the delta table can be created. And inside the delta log, if you see, I will show you. Wait. See, dot S3 optimization 0, 1, 2, 3. And if you see here, CRC and JSON. So what are these two? These are holding the metadata of that particular metadata of this particular file of this particular table, delta table. This particular delta table is having this particular metadata, means it is holding the things like who has executed this particular thing, who has created this particular thing, and all these things will be shown here. But there is some limitation I couldn't show you, because if it is in storage account, na same. Even if you write it to the storage account also, it will create all these things. There I could show you clearly, but here, even if I read the thing, I'm not able to show you completely. But I will show you the important one. Display of r.read.json of. Okay, I'm giving this one. Let's see. Okay, okay. DBFS, we need to this. See here, date change. When this has been created, the date and modification time here it has given, and the size it has taken, and number of records is 4, and all this. What is the minimum value? It is 1 age. See, if you could see all the things, minimum value, maximum value, all these things are there. Means it is holding the metadata kind of thing. This particular JSON is having that particular one. And here, if you see cluster ID, means through which cluster I have executed this one, that particular ID we have, and engine info we have. See, runtime is 12.2x and Scala 2.12, and isolation level, each and everything, what not. I have what are all the required metadata is there. All this has been created for this particular Parquet file. Okay, so this is how the delta table usually looks, and not looks. This is not the delta table. This is just a log table which is having the metadata of your delta table. Clear? Clear, everyone? What I'm trying to tell you? See here, if I expand this particular thing, na, you will be able to see metadata, format, ID, partition columns. So see, struct fields, what fields we have, and name, type, string, what each and every column and what type of column it is. Everything has been displayed here. So this is how it is. this is means this is having all these features. That is the reason why this is majorly built upon the data lake, so that we you will be able to mm, get more things. Means see, using this delta table you could see the versions of the particular file also. Okay, means I will show you that also. If I see visualization, no, wait. Visualization is not on this one, but let me read this particular delta file. Okay, the delta as a folder I have created. Okay, now what delta table? Okay, spark dot read dot format of delta. It is the same thing. Options header equal to true. Dot load off. Okay. So this is how you can read the delta file. See, it is the same thing what you have done in your while reading your CSV and TSV or JSON files. It is the same thing. Let me click on Shift Enter. Okay, I haven't showed this. Hmm. See, the data has been in a table format. So it is the same thing how you worked on that one. But see here, if I click on here, it is a data profile. You could see it is loading things. Wait, I will show you something. Depending upon the number of rows and columns we have, it is saying, no? Hmm. Remember, you have summarized one inside the data, correct? So the same thing you have seen today here also. It is the same thing. When you click on data profile, you are able to see this, right? What is the count of IDs? What is the count of ages, a salary, missing percentage and mean value, standard deviation, zeros, minimum value, median value, max value, everything. It is same, right? Actually, it is doing the same thing. Let me show you one more thing. Visualization. Okay. So here you can see this now. Let me no data it is saying. Wait. Okay. In x-axis, let me give ID. And in y-axis, let me give gender. Actually, na, it is, wait. Okay, gender is not there. ID and age. ID and age, what it has created only this particular thing. Let me go to age. Okay. So, see, it is all the ages are also similar or what? That is the reason why it is not showing anything here. But usually, na, when you create something, it will show you those visualizations also. See, this is the community version. That's why you are creating your visualization upon your own. But in Databricks, Microsoft Azure Databricks, you will be able to see the visualized charts automatically. Okay, there is no need of creating all this. Okay. Mm, yes. So you are clear about these two, right? And there is one more thing which we shouldn't be missing is table. See, you can download all those if you have multiple things and add to the notebook dashboard. So this also you can do. And see, if I click on this particular data frame delta table, here, if you see schema, ID, integer, name, string, this one you are able to see, right? Without having any print schema statement, you are able to see the schema. And if you click on details, the description, when it has been created and when it has been lost modified also, and partition columns. See, partition columns, why this is there? Because you are dealing with a delta table. That is the reason why. And irrespective of it is a delta table or not, whenever you work in Databricks, it will definitely a major thing, means partition columns, it will definitely show you. Okay, number of files and the file size. And the most important thing is history. If you see on history, version 0, timestamp, and user ID. This is my user ID, username, operation, right operation I have done, and operation parameters, and job. Job is null because it is not executed via any scheduled job, right? That's why. Notebook, session 14 notebook, that's what it is giving. Cluster ID, and all these things here it has showed us today. Okay, and user metadata, everything. And apart from all this, I could also show you uh, this history. This is version history. Okay, it is still loading, but using this particular version history, na, see, uh, so these are the two histories I have for this particular notebook. Okay, so see, I have written only this particular 3 or 4 commands and I'm checking it. But if you have multiple commands and if you could see it now, then you will be having multiple versions. If I click on this particular one, see, which is not there here and which has been added now has been showed, right? So this is how it works. Means, what I can say is through versioning means you could see all the previous. For example, you have something like you must have missed some tables or like you have executed a command, but the data which it is consisting today is not consisting tomorrow. Means, see, with the what um, with example like with whole data you could see today, right? Tomorrow also if you execute that same thing, but tomorrow if you couldn't see the data, means you can come back to the version, this particular notebook version, you can, and you can show to the client that yesterday there is a data for sure, but today it is not there, because they will not believe you, right? Straight away when you say, you need to have a particular proofs, right? That is a very minor example I'm giving you, but yeah, mostly it is used when you really require to go back and check what you have done previously. Means some code you have done and it is working previously and now it is not working, then how many times you do control Z, it will not it is not working. Then you can simply have a version history and go back to that particular version of the notebook and check it, right? So that is a one of the example how you can use this particular version history. Okay, and if you see this one comments. So see, whenever you select some code from the notebook to start commenting, here it is saying. So for all of this, so if I select this particular one and see here, I'm getting option to write something. So here I can see reading the CSV file. Okay, and I'm just giving the comment. So this is how you can comment throughout the notebook. But inline comments, there are two types of comments. Inline comments means giving the comments inside the command cells is different from giving the commands comments here. Okay, so there are two types. This particular thing you will be utilizing only when you are reviewing the code, but not every time. Okay, see, when someone of your lead or someone is viewing this particular thing, so he will ask you why you are utilizing only this particular function. So if he is having any doubt, so at that moment he will use this particular commenting mode. Okay, this you have seen, and this is ML flow experiments. This one you will be able to see only when you are working with ML machine learning. Okay, and here if you see variable explorer, language currently is Python. So whatever you run cells for selected language for variables to appear. So when you change it, then the different currently we are using only Python, na? So that's why you couldn't see anything. Let me get with some solid examples for this one, okay? And this particular thing is disabled for me. If I hover on this one, I couldn't show you. This is what visualization is. I showed you, no? For this particular one, visualization. Where is this? Visualization. This has been disabled. Actually, if this is has been enabled, this visualization would have come automatically. Okay, this is one of the feature I could say. And delta table version here you have seen is just a read one, correct? If I give you the right one also, see, the version history for this particular one is in this JSON, na, you could see, right? Where is the version number? The version number also should be there. Okay. See, anyways, here you could see, right? Version 0. And if I click on, click enter, it will create one more sample one. And let me, if I write it something like this, delta, and overwrite as, if I use overwrite, na, it will create multiple versions. Then at that moment, I am able to show you the versions, how many times it has been overwritten and all. Okay. Wait. Still here it is showing version as 0 only. But wait. I'll show you from here. Okay. DBFS. DBFS file store data input. This is delta log. No. Hmm. Actually, I couldn't expand it to show you. But see here. 0, 1, 2, and 3, 4, 5, 6, 7. Okay, so 7 partitions here it is having. But if I override this particular delta, this is the delta table actually. Okay, if I hover on this one, sorry, this particular one, you could see it, right? It is a CSV format. Okay, let me get back to something which is concrete example so that what I'm trying to show is here now you will be able to see things when it is overwritten multiple. See. So this one, how many times I have committed is 4 times. Correct. Means I have overwritten the same file 4 times. First is one which I have created, and rest three are overwritten one. So for all of them, it has created one committed, okay, and one started. And partitions also for each time it has created partitions 4 times, so 8 partitions. These two are first time when it has created, and these two are the one when I have overwritten it. So you can just create a example and just take as overwrite option, okay, and then you can experiment this particular thing, okay, then you will be able to understand this particular thing, okay. How many times you have done, those many times these partitions will be created and this committed will be created on route. Okay, try to experiment from your end also, then you will be able to understand this very clearly. Okay, so this is what I want to show you from portal point of view today. And when it comes to data lake and delta lake, so delta lake, we have ACID transactions, means whenever how you can say the ACID transactions are there, means atomicity, consistency, and all. See, what, wait, for example, I'm saying this is not a complete thing, I should say, but yeah. So when it comes to ACID properties, na, every data transaction is treated as an invisible unit. Okay, it couldn't be seen. Transaction means every time you write it means you're writing and overwriting the same thing. That particular thing is called transaction. Okay, transaction means writing the same thing again and again. That is writing something is a transaction. You consider like that, not again and again. Writing something is a transaction, you could say. Okay, and acid properties. When it comes to first one, atomicity. What does it mean? Means every data transaction is a what it is individed one, means you couldn't divide a transaction. First thing. Second thing is either the entire transaction has been gets completed, or means it will either be succeeded or it will be failed. Same as your SQL, it is also the same thing. Okay. So first thing, you cannot divide the transaction into two parts. Either it will get completed or it will get failed. So using this particular thing, it will never write the partial thing. Means it will never write a half file. That's what I'm trying to tell you. Okay. And second one is consistency. Your database is in valid state before and after every transaction. Means every time you do some transaction, before and after also it will be in valid state only. That is means breaking the constraints. It will not execute something. Okay, means beyond its limits, like it will not create and it will not create any failures. That's what I'm trying to tell you. Okay, and that is consistency. And the third one is isolation. Every transaction is not related to each other. Each one of the it is isolated. Okay, so no collision between any two transactions. And finally, the last one is durability. Once the transaction is completed, the changes are guaranteed to never be lost. So once it is done, you understood, right? Once it is done, you will never be able to lost it. That's what. So these are what acid properties are. Okay, I will be sharing you this particular PDF anyways. So for just an instance, understand why Delta Lake and Delta Data Lake are differed, and what makes it differs. It's because yes, acid properties. Okay. Anyways, we'll discuss tomorrow more on these things. Okay. Thank you all. Good night. Sir, we can stop the recording.